everyone. I am Matteo Collina. I work for a company called Nearfirm. This nice logo at the top, red one. And today we'll be talking about object-oriented development. And I don't know, we'll see. So, when I was at college, doing my bachelor and then my master, I've coded this class 1,000 of times. Oh, first of all, I'm so sorry. We have lots of UML in this talk, okay? I loved putting nice UML diagrams again in my talk because it has some feelings. So when I was at college, I think I had written this class 1,000 of times. At my first year doing my introduction to programming course, whatever, and then later on doing my database courses, and so on. And in my software engineering courses, well, we discussed that a class is composed by data and behavior. And this model is quite nice. It has some nice properties. The names are named for the phone, the emails, and a nice save action on it. So how many of you have coded something like this in their life? Okay, so this talk is for you. So if I wrote this one, I would have failed my software engineering exam. And in fact, my professor has said this is the right model. Again, maybe this is not a pass, still is not a pass, because in fact, we can have a person that you can save, okay? And just send emails that you can send, and a student that inherit from person. Nice UML diagrams, okay? Really, really cool. So, apart from this history, and we'll get back to students and persons and classes and blah, blah, blah. So what is an object? As we said, as we have studied it, is state plus behavior. And we define all of this in a class. Objects provide some things. First of all, they provide encapsulation. So we can encapsulate data inside our stuff. Oh, we have private fields. Whatever. We have accessors for accessing those fields. Abstraction, yes. Abstract classes. So how many of you love abstract classes? Okay, how many of you know how to implement an abstract class in a language that doesn't have them? Come on, it's easy. Just implement a class and not instantiate it. Inheritance. Come on, if you have abstract classes, we need inheritance, okay? And polymorphism. Do you like polymorphism? Okay. So, you know, object provides encapsulation, and objects are really needed for encapsulating stuff. In fact, we can provide encapsulations just by writing functions. So, do we need objects for encapsulations? For encapsulation? Do we need private fields? In fact, in order to access private fields, we need accessors. And how many of you have filled thousands of those dialogues in their life? Yeah, these are quite useful, okay? It's a quite useful feature. Like, you know, you write a field and then you add some nice accessors for it. And I am a JavaScript developer, and I really love the fact that we got accessors in JavaScript 2016 and ES6, or how you want to call it. This is full JavaScript, okay? This is JavaScript. And in fact, we have accessors. We can define get and set fields. We don't have private, okay? We can specify that some state is private for us. We just put an underscore in front of it as a convention, if you adopt this convention. .NET still has this convention, I think. It's quite a good convention. It's really useful, okay? Really, really, really useful. Really useful stuff. I use them a lot. So why accessors are useful, okay? And why we need them. First of all, if you want to read a property and execute some code. Maybe it's a computed property. If you have a linked list, you want to compute the length dynamically or not, depends. You want to compute some field. If you want age, and if you want the age and you just have the birth date, you want to compute it because it's something that can change over time. So you want to compute it on the fly. However, accessors are really bad when you want to send them over a network. What do? You got an accessor, and you are computing some variables, and then you want to send the stuff over the network, and how do I deserialize? I have an age that is computed, and how do I deserialize it? Do I put my accessor with my computed variable, my model on the other side as well? What if we deploy two versions of the same app? What if we change the class? In fact, we can even have inheritance. Inheritance is quite important. And we have a class that is a person, and then we have a student that inherits from person. So we want to send a student over the network. How do we differentiate if we want to send a student over the network if that is a student? If you JSONify student, the student object, you will get no idea that it is a student at all. How do we deserialize it? Oh, again, okay. Let me put the name of the class on one side and convert it in a JSON format, then I deserialize it, or maybe in XML, I don't know. How many of you have serialized the stuff in XML in their lives? Yeah, fun stuff. And in fact, well, inheritance is really good because we can inherit, and we can easily move stuff along the net and remote our classes, our big inheritance. At some point in my life, I wrote a big inheritance hierarchy of like 6 or 7 classes that inherit between each other, polymorphic stuff. Okay, well, I'm sorry. So the big question mark is inheritance good for domain data? I come to the point that I don't really like it for domain data, but I really like it for utilities. I don't know, I'm writing a controller, maybe I want to inherit from my abstract controller. It's quite useful. I think objects are really good, okay, because I can send easily over the network with JSON. I can JSONify an object, send it through on the other side, comes the same as I put it in, with no code from my side. I create an object literal, put it through, JSON, okay, yeah, on the other side, JSON parse, comes fine. So objects, I think objects are really good. And they are good for storing states. Because state can be easily moved across the network. So how many of you are not writing any applications these days that does not send data over the network? Okay, so is anybody that is writing an application that sends data over the network? Okay, so that's a second check because, you know. So this is a nice class model. I'm coming, okay? It's not even big, it's just a partial part of a thing. First of all, like how much time did this took to do this? Just the diagram, not the actual implementation. What does this communicate to you? This is a very famous open source project, okay? Something that I use and works really well still. It comes from the Java world. So that these monsters can come around. So even if the objects are good, I have really a point against classes. Really a point. And this morning, my friend Dave said something. Hey, Dave. Hi, Dave. How are you? Say something about classes and React and the fact that they didn't like them again. Yes, classes encapsulate behavior. Classes are good for storing behavior. That's why we write classes. Otherwise, we would just write literals, okay? And in fact, one of the main reasons we write classes is this one. So how many of you have put a save method or function in a class? No, I don't think the other are lying, okay? I did. So the big question mark is, are fat models good? This is a model okay? It's something that we save. And the big question is, like, is this really part of the domain of a model to save itself? To save itself? Like, is it something that should be part of our domain? Is it the responsibility of a model to save itself? Also, this is even worse. Is it good to encapsulate a database connection in a model? Because in order to save itself, it needs to have a database connection. So, and then you have a model that can save itself, and you want to send it over the network. And what happened? Ouch. How can I move around my database connection? Well, the solution for this problem is to encapsulate the model. Haha, I have a solution. I can encapsulate the model. And then I can use something like Java RMI. How many of you love Java RMI? To distribute the access to my model so that the other side can, I can call the method on the other side. Nice. Then, before that, there was Corba. And Corba, well, I don't have much to say. Then we discovered that we can do better. Sew up. And serialize everything to XML. So I'm encapsulating my object in a nice XML representation and expose the same thing as a service that accepts a big XML. I'm putting REST in this. And the reason why I'm adding REST in this is because from time to time I just say, I'm just creating a nice REST endpoint. I'm creating a, I don't know, people service that offer a nice REST API for managing people, or a nice REST API for managing talks in a conference, or for like submitting proposals to CodeMotion. And I'm creating a nice REST API just to do that, and then some other side just to distribute the access, call that REST API. And I'm encapsulating the thing on a REST API. Yes, well, for doing this, I'm creating an internal API because they have this little service. I'm doing microservices architecture. And this nice little service is a nice API, and they're really good because it's a form of communication between teams. And this is the major important thing, finally, okay? SOAP didn't achieve this. REST APIs did. This is a major achievement of REST, possibly, because it's a form of communication between different teams. So I was currently, I'm leading a team in London. Well, I live in Italy, but whatever. Remote work, you know. And which is part of a biggish thing with like 6 teams. And, you know, the commons language became a little bit more like API work and API docs. And REST API are really good for that. And these are the good API. Because my team offer an API to your team and give you docs. I maintain versioning, I maintain all the stuff. And you can access my API. And we talk this API language. It's outside my application. However, other teams, other projects, do internal APIs just for the sake of distributing things. Haha. I want to make things distributed. And wrapping them on one side, writing a client for my API, I'm writing the servers, the client, and the guy that is consuming the API. And I call these bad APIs. These are not good APIs, because I'm just writing stuff, for maintaining and writing code just for the sake of writing and maintaining code. It's not easy. At a point in another project, I implemented, every team implemented a different client on the same language for the same API. I don't know. Well, we started from one single question. One single question. We wanted to access our data, our model, which has a save method, on some boxes. And I want to just get access of my data. I really believe that no code is better than any code. Okay? Like as a team leader, if there is less code to maintain and fix, and that can break in production at 4 a.m. in the morning, and you get a call, and you scream, then it's better than not having that piece of code. So when you send a pull request or make a commit that reduces the number of lines of code, you feel really proud. Because I feel really proud because, you know, I've removed places that can break. And like, I really believe that code for the sake of writing code is full technical debt. Like, it's no point. There's no point in write code just for the sake of having some code. So, how many of you have written an adapter of an adapter of an adapter, like 3 or 4 times? So, like, this is really common for loggers. Like, you have a logger, then you write for a logging system, then you need your application as another logging format. So you use a piece of code that converts the other one. But then, oops, no, they need a different one. So you put in another layer in the middle for whatever reason to add some functionality, maybe. And you have adapters of adapters of adapters. And they don't really work. And performance goes down terribly. So the big question is there something wrong in all of this way of doing things? Are we object-oriented? Are we doing object-oriented programming in the first place? What is object-oriented programming? Well, I really recommend everybody to watch this talk. It's Greg Young. I don't know if any of you know who Greg Young is. Please watch this talk. Know this guy. It's really amazing. He talks about this nice thing. Is like I was discussing assembly code with him at some point in front of after 4 pints. Really crazy guy. And he did this talk just with one slide, that one, 40 minutes, talking about the art of destroying software and the art of knowing how much your technical debt costs. So if you're writing a piece of code that is technical debt, you know it's shit, okay? You know it's bad, but you need to put it in. The big question mark is to estimate, before putting that in, you need to estimate how much time it will take to fix that and rewrite that piece of code. If you can take that piece of code out at any time and write it in 2 weeks, then it's no technical debt at all. Because you can if that piece doesn't work, you can always throw it away completely and rewrite it from scratch in 2 weeks. So, easy. Okay? Just another 2 weeks of work. If you have a big blob of mud and which you need to take out, you need to fix a bug, and you don't know where to start because everything starts falling apart, it's no estimation. You can't estimate how much time that will take. It's not really easily decoupled. And Greg, in this talk, I want to cite him, and he says that he writes code for the sole purpose of deleting it. Like, you write code because you need to delete it at some point. I want another, like, I cite myself, and I say, oh, this shit. And yes, that's it. Yeah, this one. Because, you know, your code, like, the code is a byproduct of our intelligence and our work. We need to understand what we are doing, and then we produce code. And if we stop maintaining our code, it will fall apart. Even anybody of us that has written, completed a task, you delivered a new feature, you did a release. And after you come back to your code and say, oh, why I did write this so badly? And I can rewrite it 10 times better now. The problem is, you are not, who are you now is not the one who wrote that piece of software. You got the experience of writing, so you can do it better now. So, we were designing models and classes, and we have been designing models and classes and big class diagrams. Well, what if we design messages and not fat models? In fact, well, this is a nice introduction. So how many of you have read the original Alan Kay paper on object-oriented programming and the history of the object-oriented programming thing? Well, for when this was introduced, it was like, oh, well, each object is a little computer that send messages to each other. So where did fat models came? Like, what we did wrong? Like, it's more about the communication and their internal rather than the internal properties. What happened? Why did we get there? Can we do something different? Okay. Well, we want to do something like, let's try to model our person rather than having a big class model by having a nice another UML diagram, okay, about messages and the message exchange. So we issue a command which is change name, and then we do like we set the name and then we save. Well, what is a message? Because that's the point. We are sending messages around. We want to model our messages. So what is a message? So a message is a map, okay, that contains possibly arrays, strings, other maps maybe, numbers, binary data. So this is my major thing that I don't like in JSON. There is no binary data. And at some point we wrote these as, because these are the basic units of our code. And instead of serializing it in weird formats like XML, we just send them around using JSON, and that's why JSON has won. What about streams of data? So let's discuss a message, okay? So I have a person, and there's a name and a surname, and this can be a message. And in fact, I can send this message to a recipient. This is JavaScript, okay? I'm sorry. I write this all day. So we have a recipient that receives our message, and we have a function that is called when that is done, and we print the result. And result can be another message. So this is nice because you see the recipient has, we don't know what this function does. This function has an error. So with Java MI, you have this nice thing that you need to add to throw everything to your interfaces, and under all this network error at that point. Ouch, what happened? Here, the error is the first thing. You already get the error, okay? Error. You have the error. You have the result. You don't know if you are calling your system, a function that is implemented on your process, a function that is remote, a function that happens in another, on the other side of the ocean, that is in Australia maybe. You don't know. And in fact, this is a name, and it's a node callback style. And we have a nice song about it, and I really like it. It's a really nice, famous thing on YouTube. And you can even, like, I don't know, watch it, and I can even, there is even the audio, okay? Yes, this is HTML5. So, I need to click. Yep. This is called the node callback style. And yes, if you use Node, this is what it's happened. You can implement the same thing. It's basically own language. The node callback style is nice because it's asynchronous by default. You can use it in the browser, in the backend, on the Internet of Things. There's no difference in wrapping a database or a remote endpoint. So you have a remote endpoint, and it's just the same. Yeah, okay. If you are into promises, it's okay. I don't like them, but I'm fine with you liking them. So how do I do remoting for this kind of a function? Okay, I want to call the recipient, but I want to still implement the remoting layer because we're writing distributed systems. So, well, the whole point, the whole question mark that is missing is how do I code what function I'm calling on the other side? How do I encode the name of the recipient? Because that's the whole point of it. Well, we want to be truly multi-transfer from day 0. We don't want to write system. We don't want to write a wrapper for our REST API. Because I want to start possibly with a monolith, because developing a monolith is really a quick thing. If I want to be truly multi-transport, because if tomorrow I need pass through to provide high availability, I want to remote stuff, I need to do it, and I don't want to put any investment in doing it in the first place. Well, we can store which function we are calling in the message. So let's say we store role person and command save. So we have identified which service we are calling, role, and which command we are sending there, save. This is a nice command pattern. So I don't know, I hope you're dead by this point from my UML, nice UML. Command pattern, we don't want to implement it with using a massive switch case statement. You know, do you like switch case? Yeah, we like switch cases. Well, ifs are not good either, okay? At some point in my life, I wrote an if. I added the 33 else in an if. No, it's not good. Well, I wrote this library called Bloomrun. It's pattern matching for JavaScript. So you create an instance of Bloomrun. You call add. You add a command, command save, and you specify a function. And then you can look it up that thing using a pattern, you specifying the message with your person and the command save, and this will get executed. Then this will call us back. And let's try it. Let's see if it works. Yes, it works. Okay, it's working. So alert gets called, and this is our message. I hope you read it. I don't know if you can read it. It says saving command save person name Matteo. Yes. So let's press enter. Yeah, true. Yeah. So we call such a way of composing code a microservice, and this is how at Nearform we do them. We encode messages as JSON objects, as JavaScript objects, and send them through the network or inside the same process by specifying patterns. And we even wrote a framework called Seneca. It's been around for quite some time. You will have a nice talk from Michele Capra. Is Michele here? I don't know. It's not here. Ah, Michele. Okay, Michele is not here, but he will talk about Seneca.js tomorrow. And Seneca is a framework for developing microservices. And this is Seneca. You instantiate Seneca. You call add with your role, and you specify your function. Then you call listen. Okay? You launch this, and this is a process that stays around. Then on the other side, or on the same box, whatever, you call a client. You create a client, and you just call act to execute the microservices, and this thing will work. So features that Seneca have, well, it's truly multi-transport. From you can use TCP to service buses, Redis, RabbitMQ, SQS. I don't know. I don't remember. All of them, basically. It's really easy to write them. So you can start building a monolith and then decide to split stuff away. Because, you know, writing a monolith has its own right, but I want to be able to split stuff around really quickly if I want to. And rewrite them in 2 weeks. It has some deep inspection and debugging tools, really nice ones. It has a nice authentication user management system already built in. So you can install Seneca user and you will get user management for free. It has a nice control panel. And I don't know, it is integrated with a framework called Happy. How many of you have heard of Happy? Oh, somebody, hi, nice one. Okay, I will show some Happy stuff now. Oh, I have a demo, okay? And I will see, because I need to all this stuff and type it with one hand. So if I mistype, please help me out. So here we go. This is my thing, ls. So we have a devices file. And in devices, as you can see, we create a Seneca instance. We have a UUID, a devices object, which is our database. Because I'm really lazy, I didn't want to have a database. I'm just using a fake one. And I'm allocating a new object and putting it in my big thing. And I just call save. So I am adding my role here and add another one to list them. And then I call act to execute some stuff. So I save 3 entities, and I look them up, and I call console log at the end. So let's run this. This is a nice little thing. It's a monolith, okay? Oh, nice, okay. So you can see here, all my stuff gets saved correctly. Okay, so now let's split it up in a plugin. So Seneca has a nice concept of plugins. So in fact, we can see like that we have two files. So now I have devices, and devices just offer a function that is built, and they just call, does two adds, and exports it. There's nothing in there. And then if I open standalone, is the code I had before. I just added use devices. So I can use my module, my plugin, and call some stuff in it. So let's run standalone. And node standalone. Still working. Now I can do something better. And now I have 3 files. And if we look it up at standalone, now it just use devices called listen. So now we can do 2 things. We need 2 terminals now, and I need 2 ends. So I'm running a client now, and the client is still working. And what is the client doing? The client is creating the client and calling act, as before. Nice. So what can we do? We can do better, okay? And what we can do is can't remember. We can expose this as we can expose this as a REST API because we need to do good communication with other teams. So let's open it up. Happy. What's the name of the file? We have one more file there, which is server. We open server, and as you can see, we have our server. We use the Chiro plugin, and the Chiro plugin exposes my Seneca instance through REST endpoints. So we call server Seneca use devices, and we specify get devices, and we call reply act, which will forward this to the Seneca instance. And this is the same. You also have some validation, automatic validation, and we call reply act. So let's run this. Yeah, nothing in there. Because, you know, we haven't inserted anything. So let me see if I can insert something. And I hope I remember this correctly. And let's see how it goes. Ouch. And I need, name, payload. My quote. Oh, yeah, I need to do one thing. Because we are sending in JSON. Ouch. What did I do? Ouch. Wrong thing. Told you I needed 2 ends. Yeah, this has been stored, and now I can curl it. Oh, this is my thing. Okay? And I used the same stuff as before, exposed it as a nice endpoint. Now I can even open up localhost 3000 and open up the docs. Whoop. Nope. It's doc. Oh, yeah, no, sorry. I need to change branch. So now I'm launching it, and thanks to docs. Here we go. So we have automatic documentation of our endpoints, and even look it up with our nice things. And if you look at the code, what we did to do this was quite easy. What we did, we just added 3 plugins to Happy. And I got automatic documentation. So, after this, it's time to wrap up. This presentation is available at this URL. This presentation is HTML5, so you also can browse it on the web. And the demo is available here. So, well, this is me. I have time, still time. I am good. And yeah, so this is myself, and I don't know, doing a little bit of stuff. I am part of Nearfirm. From December, I'm part of the team that developed Node Core. So if you're using Node.js 5.7, there is a piece of code that I wrote. I'm really proud. And I'm part of the team that maintains Seneca, and I do some other things on the Internet of Things that you probably can look it up on the web related to the MQTT protocol. So it's time to say thank you to watching me, and I hope you have questions. So if you want to contact me, these are my details. You also have cards, so if you want to bother me on the phone, you can do that. And tweet me at Twitter. It will be really, really nice. And it's up to you if you got any questions. No questions. People living. Still no questions. One question.
Oh, now it works. Well, I think that I don't know, the object-oriented is not very different from. I think it changes based on the approach. If I use a particular design pattern, the object-oriented is okay, respected, and also I have the possibility to separate the domain model to the fat domain model. What I mean is that I don't have to put a save method inside my model. I can use it just like a message. Okay. For me, a message is an object without behavior, just state.
That was what I wanted. Yes, that's the point of. That's what I was trying to. We are in agreement. That's what I was trying to explain in the talk. If you have a message, the problem is like the idea of object-oriented programming says that you have behavior and data. And the moment you split it up and you start talking about messages and moving stuff around, is not what you were doing in putting like the classical way of doing object-oriented programming.
But is it mandatory to use behavior in an object, or?
It's not mandatory at all. Like that was my point. Like it's more about the fact that we have been taught something, and right now what the right way of doing things is going against what we have been taught. Yes, of course. It's true object-oriented programming. Alan Kay object-oriented programming. Any more questions? Yes.
Maybe it's not pertinent with the talk, but why you don't like promises?
Okay, I will answer one question to one statement. I don't use semicolons. That's why I don't like promises. That's the answer. Yeah, I'm joking. I'm not replying to that question. We can talk about that later. Usually performance. That's slow. Sorry? Sorry, can't hear you. What's the question? Okay, it's a joke. Okay. Oh, I will promise to answer later. Yes, of course. Of course. I promise to answer later. We can keep it on in front of a beer. Or on the watch, or on the ring. I'm trying not to die. So again, thank you. Also, I have to say, one more thing before you leave. If you want to work remotely, do microservices, Node.js. We are hiring. So come forward. Don't be shy. Okay? Thank you guys again.